Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you another problem of related rates. So let's say we have a ladder 10 feet long rest against a vertical wall, and if the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall? So how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Now, as I said before, it is always a good idea to try and visualize the problem that we have here. So that's what we're going to do first. We're going to just sketch a simple diagram of this problem, a simple picture. Now let's say this is a vertical wall. Yep. Okay, so now we have a 10 feet long ladder, so we have something that may look like this. Yep. So this could be the ladder. So this is 10 feet long. Now next you can consider the distance of this point to the bottom of the ladder. So maybe we can call that this is point P. So the distance from P to this one can be given by X. So the distance is X. Okay, so X is this one. Now the same thing can be said for this one. So the distance here will be Y, represented by Y. Alright, now what information that we have next? We have this one here. The rate is 1 feet per second, and this rate here represents the rate of bottom of the ladder sliding away. That means the movement of X, the distance. So the rate here represents the change of distance here when it slides away, when the ladder slides away. So the rate can be said as dx dt, because it represents the change of X. So bottom of the ladder slides away, so this is the rate is dx dt, which is 1 feet per second. Now the question is asking you, how fast is the top of the ladder sliding down? That means this top here is going down. So when it's going down, because of this bottom here sliding away, that means I'm just going to sketch. Okay, so this one, so the bottom here is sliding away in this direction. Therefore the top of the ladder will be sliding down on this direction, and therefore how fast is the top of the ladder sliding down? This is actually talking about the rate of dy dt. So what is dy dt? Because when it is sliding down in this direction, that means there is a change in the distance of y. So dy dt, so how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So when the bottom, which is X, is equal to 6. Okay, now before we can do anything, we need to be able to come up with a formulation. We need to be able to come up with the equation that relates X and Y and the information that's given here. So it is obvious that this is a right angle triangle, and due to Pythagoras theorem, we can construct an equation where we have x squared plus y squared must be equal to 10 square. Okay, 10 square. Now next we have x squared plus y squared is equal to 100, and here we have to differentiate. So we're going to differentiate the left hand side and the right hand side. This is an example of applying implicit differentiation. So now I'm going to differentiate that with respect to t, because now we are looking at how fast is the top of the ladder sliding down the wall. So it has something, it's dependent on time. So now we're going to differentiate that with respect to t. So x squared plus y squared and dt 100. Okay, this one can be separated, so we have dt x squared plus dt y squared is equal to 0, because you differentiate this is a constant, you will get 0. So next I can differentiate this. I can consider this as an outer function. Now we go back to the idea of chain rule. So this is the outer function 2x, and x is a function itself with respect to time. So when you differentiate x, you will get dx dt. Okay, next you differentiate this outer function, you will get 2y, and y is a function of t itself. Y depends on t, so when you differentiate y, it will be dy dt. So recall some implicit differentiation exercise which you have done before, and the idea of chain rule, and you get to apply them here. So it's equals to 0. Now next dx dt is given, which is 1. Dy dt is what the question is asking you to find out. X is equal to 6, so we are just going to substitute all the values that we have. So now 2 times 6 dx dt is 1 plus 2y dy dt is equal to 0. So next I have 2y dy dt, therefore 2y dy dt must be equal to negative 12, and dy dt must equal to negative 12 over 2y. Now if we go back to the original statement that we have here, I can see that if x is equal to 6, okay, x is equal to 6, you can substitute that into here, you will get what y is. So in this case, if you substitute x equals to 6 in this equation, you will get that y will be equal to 8. So we can use it here. So now we have negative 12, 2 times 8. So this will be 20, this is 16. So 4, negative 3. So you just simplify that further. So this will be negative 3 over 4. So this is the answer that you're looking for. What is dy dt? So the answer is negative 3 over 4, and the unit is feet per second. Okay, so this is the answer, and I hope that you do understand why the sign here is negative. This is because the distance here, when the bottom of the ladder slides away in this direction, the original distance, which is this one, becomes decreasing. So it will decrease over time, because when the top of the ladder is going in this direction, the distance here is already increased, it is already decreased. So negative here represents the distance being decreased. So ladder is sliding down at a rate of 3 over 4 feet per second. Okay, thank you very much for watching. I'll see you again in the next video.